We're going to talk about types of triangles. Okay. So you have by angle and then by side. Okay, and then you can have a combination of the two. Actually, let me paste this in. And so when we're talking about a triangle by the angles, we're looking at all of the angle measures, okay? If all angles so if all of our angles are less than 90, we have an acute triangle.
Is this from you? Oh, I'm sorry.
Yeah, I'm going back to the beginning. So if every angle is less than 90, it's an acute triangle. Now, even if you have a right triangle or an obtuse triangle, you're going to have acute angles. So all of the angles have to be less than 90 for it to be an acute triangle. Okay. If one angle is equal to 90, that's when you have a right triangle. Now the other two angles are going to be acute because the triangle is always going to add up to 180. So if one of them is 90, the other two are going to have to add up to 90, so they're going to be less than 90. So we're looking at, if you suspect right or obtuse, you measure the largest angle. If the largest angle is equal to 90, then you have a right triangle. If the largest angle is less than 90, it's an acute triangle. And if the largest angle is greater than 90, it's obtuse.
And you said that for the right triangle, that the other two angles have to be less than 90?
Yes. I'm running out of room. Okay, that's obtuse. Now, we have one more type, and I'm going to have to try to squeeze it in here somewhere. I'll put it at the bottom over here. And that's if all angles are equal.
What do you mean? So one angle equals 90 minus right.
No, if one angle equals 90, it's a right.
And if all angles are equal, that's for the last one only?
Yeah, so if all angles are equal, they're all going to be 60 degrees because you have three angles in a triangle. 180 degrees divided by 3 is 60. So if they're all equal, they're all going to be 60, which is also acute, but it's a special kind of acute, and that's equal angular. Yeah, when all the angles are, no, all the angles are equal angular.
Right.
Yeah. Now, which brings us to an interesting point, though. If all the angles are equal, so are all the sides. So let's talk about the sides for a second. If we have two equal sides, yeah, that's more isosceles. And that's exactly two equal sides. If we have no equal sides, that's more scalar.
So only when the angles equals 60 each?
That is an equal angular.
60 only.
60. All three of them are 60.
Okay.
And then the last thing we have is when all the sides are equal. So all three sides equal give you equilateral. Okay? angles in blue. We've got sides in black. Okay. And then we have a special situation with these two, equilateral and equal angular. They're the same. Okay. When you have an acute triangle, so all your angles are less than 90, you can have 2 equal sides or no equal sides. You can also have all equal sides but your angles will be equal too. But I can have an acute isosceles, I can have an acute scalene. I can have a right isosceles or a right scalene, and I can have an obtuse isosceles or an obtuse scalene. Those can all kind of go together. If you are equilateral, you are equiangular, and if you are equiangular, you are equilateral. These two are the same. So the two that start with equa, if you're one, you're both. So I can't be an equiangular scalene. That's impossible. Does that make sense? So I can make combinations of these blue ones here on the left with the top two of the side lengths, but the ones in purple box are always together. If you're one of these, you're the other. And then if you're acute, right, or obtuse, you can be isosceles or scalene. Does that clear it up a little bit better? Okay, so I'll tell you to classify a triangle by angles and sides, or one or the other, but we're going to just do both. So the first thing I'm going to do is I'm going to measure these angles. I'm looking at this is an acute triangle because none of the angles is 90 or larger, but I'm still going to measure them just to double check myself. Because 90 degrees is exactly straight like that, and obtuse is going to be bigger than this, so anything past there. So I already know from looking at this that it's acute, but I'm going to just measure it to show you guys how to measure it and double check myself. So I'm going to measure this corner angle first. In the center of your protractor, there will be a dot or a line. You line that up with the vertex, and the bottom of your protractor gets lined up with the bottom of the triangle. And then I come up here, and I'm going from 0 up. So this is a 65-degree angle. Okay, and that one was nice because it was in the right direction. Once we get to the other angles, we're going to have to flip things around and get a little bit wonky. So I can measure this one, this direction. So I go on the outside numbers. So I'm going from 0 up. So this one's 45. Okay. And then this one is where I'm going to have to flip things over. And I'm measuring along this way, and it looks to be about, it should be 70. Yeah, 70. Okay, all of those are less than 90, so I know it's acute. Okay. And then I'm going to measure the side lengths to see if it's scalene isosceles. I know it's not going to be equilateral because my angles don't match. So this is approximately 20.5 inches. And then this side is about 19.5. And this side is 15. None of those match, so it's an acute scalene.
Question: if all the angles are different, is it going to be scalene anyway without measuring the sides? Right.
Yeah, we haven't gotten that far. But yes.
And it wasn't really necessary to measure that last angle, right?
We could have just assumed it was going to be less than 90 because these added up to more than 90.
Huh?
A triangle adds up to 180, right? And so if you measure 2 of your angles and they would add up to more than 90, then the other angle would have to be less than 90 because you largest at that point, right? So, let's try another triangle.
That is.
Now this one, I tried to get it really close to 90 degrees up here. So this might be 90, it might be a little more than 90, it might be a little less than 90, I'm not sure. But you can tell that's the largest angle. So I'm going to measure the largest angle first and see where I am. It's about 92. Oops, again, using the right pen helps. So it was really close, and by eyeballing it, I might have said it was a right triangle, but it's not. That's why we always want to measure that. Once I know that this is greater than 90, I know that it's an obtuse triangle. I don't have to go any further with that. Now, what I don't know is if it's scalene or isosceles.
So if it was just 90,
It would be a right triangle. Yeah. So I'm going to measure the two legs here. I have 15 and a half. And 12 and a half. So I already know that that's going to be a scale. So this is an obtuse scale.
So we don't even need to worry about measuring the other two.
The other two angles, no, once you know that this is 90 or more, it's going to be right or obtuse. Because we only have 180 degrees to work with. And there's only ever going to be one right angle or one obtuse angle because of that. And then once I know that this is the largest angle, I know that this is the largest side. So I don't need to measure that side. I know it's going to be bigger than these two sides. So I just need to see, do these two sides match or not? Okay, the things that we know that will help us to find the angle measures in triangles and triangles that are stuck together, like in the quiz. We know that a triangle has exactly 180 degrees. So if I add angle 1, angle 2, and angle 3 in a triangle, it will always equal 180. So we know that. We know that vertical angles are equal. Okay, and vertical angles occur when two lines cross, like this. And so this angle will be the same as that angle. And this angle will be the same as this angle. So we know that. So angles across from each other being made by two straight lines will be equal. We know that angles that make a straight line so a linear pair add up to 180. Okay, so if I have a straight line and I have two angles, this is angle 1 and that is angle 2. Okay. That we talked about, we have that exterior, sorry.
Also, we're going over. I thought you were just showing him something.
Exterior angle here. Okay, and that exterior angle theorem tells me that if I have a triangle with an angle outside, this is my exterior angle. Okay. And then this is my remote 1, and this is remote 2. These are the remote interior angles. Okay. This angle is equal to remote 1 plus remote 2. Do you have to use this theorem? No. It's a shortcut. Because I can still find this angle because a triangle equals 180. And if I know these two angles, I can find the third angle inside the triangle. And then this straight line equals 180. So once I know this inside angle, I can use that 180 to find this angle. So there's more than one way. If you know these two angles and you're looking for the exterior angle, you just add them together. But that's just a shortcut. Yeah.
I don't get it.
So if you have like one angle on the inside and then you need to find the one on the outside, you just subtract. Just do that, right? Just subtract.
If you know,
180 from whatever it is inside.
you have to know at least 2 of the 3 to find.
The outside angle?
There's always, if we're talking about these 3 angles, and I want to find the outside angle, I have to know these 2 inside angles.
Okay.
If I have the outside angle and one of the inside angles, I need to have at least 2 of those to find the other inside angle. You're always going to have 2 to find the third. So I can't give you something like this and tell you that this is, say, 45, find this. You don't have enough information. I have to tell you one more angle in here for you to be able to find that exterior angle. So if I tell you that this one is 30,
You add those together?
yeah, x would be 45 plus 30.
Basically what you're doing is because if you add those 2 angles together, you need to get 180 for a triangle. And then if you basically subtract what that angle is to make a linear pair, you're going to get 180.
Yeah, that's
Okay,
how
I
it
get it
works.
now.
Because the triangle adds up to 180. This whole triangle adds up to 180. And this straight line adds up to 180. So what happens is, let's say this is y. Let's call it y. 30 plus 45 plus y equals 180. And this is x. Well, x and y also equals 180. Because this is a straight line, and this is a triangle, and they both equal 180. Well, if these things both equal 180, I'm adding to y, so that means they have to equal each other. Because that's why this theorem works. You don't have to use this theorem. It's just a shortcut. You can find x by first finding y by using the triangle as 180, and then figure out that y is 75 that way, and then subtract from 180 to find x. You can do that. That's just an extra step.
What? I thought x is 75. No,
It is.
Y is 90.
Sorry. These are 75. You'll subtract from 180 to find y, which would be 95.
And then you subtract 180 minus 95, right?
Yeah. So y, that's not right enough. So if I do 180 minus 30 minus 45, so 180 minus 75, I'm going to get 105, that would be y. So 75 plus 105 equals 180. 75 plus 105 equals 180. So that lets me know that these are the same, but as I said, there's more than one way to get there. So the things that we absolutely know are these three. Then this theorem is a shortcut. So that if this angle isn't labeled and you don't need to know it, you don't have to find it to find x. You can find x if you just know these two on the inside, but they have to be on the other side of the triangle. Does that make sense? Okay, so let's try some problems. Okay, so I have this triangle designy thing. And I know that this angle out here is going to be 28. And this corner here is 93. And I want to find angles 1, 2, and 3. Okay, so remember what we know. We know straight lines add up to 180. Triangles add up to 180. And vertical angles are equal. Vertical angles. So what's angle 1? Okay, and then like I said, I tend to like to label them right here, so I can see what's happening in the picture. Okay, once I know this is 28, I can use that to find angle 2. So maybe 180 minus 93 and 28.
59.
Yeah?
59, yeah.
Cool. Okay, so that's angle 2. And then to find angle 3, I have two ways to get to that. I can either use the fact that this is 59 and subtract from 180, because it's a straight line. Or I can say I know these two, which are the remote angles, and I can just add those together. Which do you like better?
Which two? 93 and 28.
Yeah, 93 and 28. So I can add 93 and 28, or I can subtract 59 from 180. Yeah.
Is that rule always correct?
Yeah, the rule is always correct. Yeah. Now, the only time, see how this is 28? This would not be considered an exterior angle because it doesn't make the straight line with the triangle. This one would be an exterior angle, and so would this one. Because they make the straight line with the edge of the triangle, but the 28 would not be. So that's the only time that that doesn't work. But since this angle 3 is making that straight line, it'll always work. So what do you like? Yeah, Steven.
How do you know those two are the remote angles between 80 and 93?
Because we look at the corner of the triangle where the exterior angle is, and you go to the other two corners. You know how they, like in boxing or whatever, they'll be like, go back to your corners, and the corners are on the opposite sides from each other? It's kind of the same thing. The exterior angle, we were looking at the corners on the opposite side.
Okay.
Does that help? Yeah. Okay. So do you want to subtract from 180, or do you want to add?
Just odd.
I like adding. Adding's easier, right? So that's angle 3. And we found them all. A little better?
I thought you had 93, 50.
No, this one's 59. These two together, the other way I could find angle 3 would be 180 minus 59. Because those two together will add up to about 180 because they're a straight line. So you can do these, add the angles on the other side of the triangle together, or subtract the one next to it from 180. So we're going to find all these missing angles. And like I said, I numbered them out of order, so I can't find angle 1 first. It's impossible.
You find angle 4 first?
I would find angle 4 first. And to find angle 4, I would use the fact that these add up to 180. So 30 and 33 make 63.
117.
So yeah, so angle 4 is gonna be 180 minus 63. So what would I find next?
2,
Which is
117. And then you can find 3 by adding 117 and 35. And then subtract, when you from 1, and then find 1.
Oh, y'all wanna look so fast?
okay. So I added these two. We added these two together, the 117 and the 35. That gave me 152.
For angle 3.
And then angle, well, not angle 3 is not 152, but another angle is
1 is because it's across.
angle 1. Perfect. And then to find angle 3, I'm subtracting 152 from 180,
Because that angle makes 180.
which give me better.
A little bit.
Yeah, I can do 50 plus 85.
And then subtract it from 180.
Let's get 135.
And then you could add 45 and 85 to get angle 3. Subtract that from 180. And then you can add, 50 and 80.
Okay. I don't.
Hold on, we'll go back to it. 138. What angle is that also?
That's 285.
And then 180 minus 138. Okay, so here's the path that we took. 85 and angle 1 are vertical angles, so that's why angle 1 is the same, 85. And the three angles here add up to 180, so I added 85 and 50, get 135. Subtract that from 180, get this angle to 45 degree angle. And then these three angles together here add up to 180. It's gonna make a straight line. So 45 plus 85 gave me 130. Subtract that from 180 to get the 50. And then once I had 50,
Hold on. Okay, so 45 plus 85, it gave me 130. That's angle 3.
that's this
Right.
angle here. These two. So I had to subtract from 180 to get angle 3. Because all three of these together are going to make that straight line. Does that make sense? 88.
Oh, it's 80. I thought it was 80.
Yeah, I'm sorry, it's 88.
And to get angle 4, you added 50 plus 88 minus 185, right? I mean, 50
50
plus
plus,
80. I mean, to
Here?
get angle 4.
yeah, 50 plus 88 gave me 138. Now 138 is the sum of the two angles inside the triangle, but that's also angle 5. So once I added these two, I knew this one
So, to get angle 4, you subtract the 180 minus 138.
to get the 42. So we followed the path kind of, well, it was a path through the triangle. We went la 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 la.
And then to get the 5, you added 50 plus 80.
88.
Question?
Good? Okay, if we have something like this.
Is that 3x plus 4 there?
Yeah, 3x plus 4. There's two ways I can approach this. I can find this angle here, and then add the three angles inside equal to 180. Or I can add the two angles that I have here equal to 140.
Do the inside angle.
I'm gonna do the inside ones. Okay, so if this is 140, this is gonna be 40, because these two will add up to 180.
Okay.
Okay, so then I can say that 3x plus 4 plus 8x plus 4 plus 40, 40 equals to 180. Because the whole inside of the triangle will equal 180, right? Then I can add 3x plus 8x. And then 4 plus 4 plus 40. Subtract 48. And x equals 132. Divide by 11. And x will be 12. Okay, so this is option 1 to find x. Option 2 would be to use that these two angles are on the opposite side of this 140, so I can add those together. And set them equal to 140. And I get 11x plus 8 equals 140.
Well, you get,
Where'd I get which? Did this one make sense?
I was still writing.
Okay, so these three together add up 20. That was this part. And once that's up there,
Oh, you're combining the x's together, that's why you got that 11x.
yeah. Now I can, like I said, I can use either the whole triangle adds up to 180, or I can use these two angles together add up to this angle on the outside. That's this one. So 3x plus 8x is 11x, 4 and 4 is 8. Subtract my 8 from both sides, and I get 11x equals 132. Divide by 11, and x equals 12. So as you can see, either way, same answer. So if you see one, but you don't see the other, that's okay. You do the one that you remember. Either the whole triangle is 180, or the two opposite side angles add up to exterior angle. Once we know what x is, we can find those two angle measures if we want to. 3x plus 4 would be 3 times 12 plus 4, so that's 36 plus 4. So that's also 40. And then 8x plus 4 would be 3 times 12.
You're just
Or sorry,
checking
8
it right
times
now?
12 plus 4. No, I'm finding the angles. So 8 times 12 is 96 plus 4 is 100. And then to double check yourself, 100 plus 40 plus 40 equals 180, so you know you did it right. Yeah.
That's really bad. I'll make it really bad, but that 8x plus 4 is like it's
Oh, no, I didn't draw right. Yeah, I just didn't draw right. When I draw things on the board, they're not always to scale. But you're right, it wouldn't be 100.